In this video, we'll start with the third experiment of digital electronics, that is the use of adders and subtractors. So the aim of this experiment is to study the working of half adder, full adder, half subtractor and full subtractor along with the truth table. So adders and subtractors are very commonly used in digital circuits. Simply put, adders are used for adding two or more bits and subtractors are used for subtracting two or more bits. Over here we have the half adder and the full adder. In the half adder we have two inputs A and B and we get two outputs, that is the sum and the carry. But the carry isn't used anywhere again. But in a full adder we have three inputs, that is A, B and C, and in a full adder the carry from a previous addition can also be used. In a full adder again we get two outputs, that is the sum and the output carry. In a half subtractor, we have two inputs A and B, and we get two outputs, that is the difference and the borrow. But in a full subtractor, we have three inputs, that is A, B, and C. And in this case again, we have the borrow from a previous subtraction that can also be used over here. And again, similarly, we get two outputs, that is the subtraction of the bits as well as the output borrow. So the apparatus for this experiment again is the baseboard, a couple of ICs and a few jumper wires. The procedure is very similar to the first two experiments. We will have to mount the IC in any one of the 10-pin sockets. You will have to look at the diagram, the pinout diagram, and make the connections for the VCC and the ground. Then you will have to figure out where the input and the output pins are, and you can connect the input pins to logic 1 or logic 0, and you can connect the output pins to the LED box or the 7 segment display. You can vary the inputs and you can observe the output on the LED box, and then you can verify the truth table using whatever outputs that you obtain. So this is the circuit for the half adder. For the half adder we require an XOR gate and an AND gate, and over here as we can see we have two inputs A and B and two outputs, that is the sum and the carry. Then moving on to the full adder, we use a more number of ICs over here. So we have three inputs over here, A, B and the previous carry, that is Cn minus 1, since it comes from the previous addition. And we have two outputs over here, the sum that adds A, B and C and the output carry bit. Then we have the half subtractor circuit. Over here we have three ICs. We have an XOR gate, an AND gate and a NOT gate. We have two inputs A and B, and we get two outputs, D which denotes the difference and B which denotes the borrow. And in the full subtractor circuit we have more number of ICs and also an extra input. So the inputs are A, B and C which is the borrow from a previous subtraction, and we get two outputs again, D that is the difference of A, B and C, and the second output is again borrow that may be generated from the subtraction. Over here we have the truth table of all these four circuits, the half adder, full adder, and the half subtractor and the full subtractor. So it's visible over here that for the half adder there are two inputs A and B. We get the sum and the carry as the outputs. For the full adder we have three inputs along with the input carry, and for the output we have the output carry. For the half subtractor we have A and B as the inputs and the difference and the borrow as the output. And for the full subtractor we have A, B as well as the borrow in as one of the inputs, and we have difference and borrow as the output. In the next part of the video, we'll demonstrate how to make these connections on the mobile lab and how you can verify all the outputs that you receive using the LED box. And using this process, you can verify all these four truth tables and you can note down what you observed and what you learned from this experiment.
So now we are implementing the full adder. So to implement it, we will require three ICs, which is IC7486, which is XOR gate, IC7408, which is AND gate, and IC7432, which is OR gate. Now after implementing the ICs, now I am connecting the wires. So for all the ICs, the pin number 7 is common, which is ground, and pin number 14 is nothing but the plus VCC. So at first we are connecting it. Number 7 to the ground. Now after connecting the plus VCC and ground, we have to make the proper connections to implement the circuit. So for that you must watch carefully to the circuit diagram and implement it properly. So these are our inputs of it. So when we see the circuit, at first there is the XOR gate, which is IC7486. So the first two are the inputs which are given to the IC7486, and its output is again given as input to the another IC. So and this is our third input, as full adder require 3 inputs, so these 3 are our inputs, and the output of the another of the second XOR gate is nothing but A XOR B XOR C, which is nothing but our sum. Now to implement the carry, it is given, the inputs are again given to the NAND gate. So here we are giving the same inputs by just altering them. So pin number 1 and pin number 2 of IC7486 and IC7408, which is AND gate and XOR gate, are shorted, so that if we give input to any of these IC, the input will remain the same. Now for implementing the carry part, both the inputs are given to the NAND gate, and the output of the NAND gate is given to the OR gate. Now there is the second AND gate, whose input is the sum. Whose input is the output of first XOR gate. So and the second input is nothing but the C. And output of that AND gate is given to the OR gate as the input, and both the input add and gives us carry. So that was the implementation. Now let us verify the truth table of full adder. So after making the proper connections, now let us verify the truth table. So in the first case, when all the 3 inputs are connected to the ground, which is logic 0, so if the expected output is 0, so let us check. So yeah, none of the LED is glowing, so we can say that when all the 3 inputs are 0, the output is 0, which is the sum is also 0 and carry is also 0. So the brown wire here indicates the carry and the orange wire here indicates the sum. Now let us check what if any of any of the input is given as plus 5 or logic 1. So now here we can see that the sum is 1. So when any of the input is 1, which is 1 0 0 0 1 0 or 0 0 1, at that time our sum will be 1 and carry will be 0. Now what if the two inputs are logic 1? Now let us start the implementation of half subtractor. So for that we will require 3 ICs, which is IC7486, IC7404 and IC7408. So half subtractor has two inputs, which is input A and input B. So before making all the connections, we have to first connect the VCC and ground for each IC. So let us connect it. So pin number 14 of each and every gate must be connected to the plus 5 volt, which is VCC. And pin number 7 of each IC must be connected to the ground. So now after connecting with all the VCC and ground, we can start our connections. So these are the pin A and B, which are given to XOR gate, and the output of the XOR gate is nothing but the difference. Now for borrow, we have to give the same inputs to the to AND gate. This is the first input, and the second input which we are giving to AND gate, it must be bubbled, or basically it at first must be given to the NOT gate, and then it must be given to AND gate. And product of these two is nothing but our borrow. So that was our connection. Now let us check if our truth table is verified or not. Now let us verify the truth table of half subtractor. So this is the first state in which both the inputs A and input B are given 0. So none of the LED is glowing. So we can say that for input A, for both the input 0, the difference and borrow both are 0. Now what if A is 1? So here A is logic 1 and B is logic 0. So for that the difference is 1. So here we can see that the one LED is glowing, which is for black wire, which was our difference. Now what if the connection is swapped? So if A is 0 and B is 1, so now here we can see that both the LEDs are glowing, which means our difference as well as borrow both are 1. And for the last state, which is both the input are 1, and for that none of the LED is glowing. So we can say that for both the inputs as logic 1, difference and borrow both are logic 0. We have verified all the 4 states of half subtractor.